The only metric of success as a company is regulating open source. We reached out to every computer science department. My sense is that open source is just better.
Welcome to another episode of the Accelerometer. I'm Dr. Matthew Mirman, and today we have Daniel Lenton, CEO and founder of UniFi. UniFi is a company that's working to simplify the fragmented AI stack. I'm very grateful to have Dan here. We've done a few interesting things together in the past, went through YC together, and yeah, I'd love to hear a little bit more about what UniFi is working on.
Yeah, awesome. Well, first of all, really great to be here. Very excited to chat with you today. So high level, UniFi is, as you say, looking to unify and simplify the fragmented AI stack. So one of the main things we've released is this framework called Ivy. Ivy is an open source machine learning framework, which effectively makes it possible to write code once that supports all frameworks, but it also makes it possible to convert code between the frameworks. So you can take TensorFlow code and convert it to PyTorch. You can take JAX code and convert it to TensorFlow and whatever. And that operates at the level of individual functions, but also layers of a network, full libraries, networks, and so on. So you can take the whole thing and convert it between frameworks. And that's very good when you're doing R&D and trying to navigate these fragmented tools. UniFi more broadly, aside from just the framework Ivy, we're now focusing very much on our deployment engine, where effectively you can upload your model and we can then get the deployment performance much faster. And I mean, I'll try not to monologue too long, otherwise I'll talk forever. But the high level here is that the fragmentation in the field goes beyond just the frameworks. There is fragmentation in the orchestration tooling, which is kind of Kubernetes, and it is serverless GPUs and all this kind of stuff. It's then also the compression techniques that are available, the compiler infrastructure, and the hardware. And for us to really get deployment pipelines running as fast and cheaply as they possibly can, you need to take a very holistic approach and understand all levels of the stack and how they interact. And this is what our engine is able to do by taking the very, very best of the open source tooling, the proprietary tooling, and synthesizing these things together to get recipes that are very fast and better than the sum of the parts effectively. High level, that's what we're doing at UniFi.
So what led you to start working on this?
So originally it was when I was in my doing my PhD. So I was in the Dyson Robotics Lab working on 3D vision robotics. We had a lot of people in the
Dyson
lab. Robotics Lab. That's what it was called, yeah.
Was it like Dyson vacuum robotics?
Exactly. So it was a lab that they basically are sponsoring and so on. So doing robotics and vision research under their umbrella. So basically it was when I was during my PhD, and we had a lot of people using a lot of different frameworks and a lot of different tools. So we had people do internships at OpenAI, at DeepMind, at Meta, etc. I personally interned at Amazon working on their drone program. Everybody would come back and be using different frameworks. So quick chronology of machine learning frameworks, like in 2015, all of us were using Caffe, the C++ library. 2016, it became much more popular to use TensorFlow, this kind of Python API, but it still had this static graph. I won't get too technical. Then PyTorch came out in 2017, something that everybody's familiar with. But at the time, there was a lot of people using a framework called Chainer. I was using MXNet at Amazon. A lot of people moved over to JAX when they interned at DeepMind. And as a lab, it was very hard to collaborate together because we couldn't share code because we were all using totally different frameworks. I found this annoying and for some reason took it upon myself to go deep down into this infrastructure problem and went down this rabbit hole trying to make it easier for us to share code together and collaborate on projects. And that worked. And that was what birthed Ivy, the open source framework that is, the main thing that people are using now that we've created at UniFi. And so that's kind of where it started. It wasn't a company, it was just a personal project I made to alleviate a personal problem. And then actually the VCs started to reach out. It was cold inbound from VCs who saw we had some open source traction and were interested if we wanted to make a company. And lo and behold, I did. And that's kind of where things have gone. But that's more or less how things started.
So when you first released the project, how did you initially get users?
So initially, well, first of all, we just did a Twitter release, and this is in
Twitter release.
Yeah, I don't know if that's a phrase, but we did a Twitter release.
A Twitter launch.
A Twitter launch, exactly. So it was in like February 2021 initially, and I just put it out there on Twitter. I mean, I did ask a few friends if they could, like it or repost it and so on, but not many. Kind of maybe 10 friends I asked if they could, amplify it, and that did pretty well. We got like 250 likes or something, and got like, I don't know, 14,000 views or something on the tweet. So considering my Twitter profile was non-existent, I was quite pleasantly surprised with the attention it got. We got like 200 stars, and we got people starting to use it and download it and play with it. But not kind of crazy. It was kind of in the dozens at the beginning. I think one of the things that's really enabled us to grow the users was actually, so we've done this big hiring push. We reached out to every computer science department we could find pretty much in the world, got our internships advertised at these computer science departments, put ourselves on a lot of job ads and on a lot of job boards. And my thesis is that exceptional engineering talent is universal. It's all over the world. You don't need to have gone to Harvard or MIT or Stanford to be a top engineer. And that's something that we've really found during hiring. So we wanted to just put the word out everywhere, do totally merit-based hiring, trust our own instincts, pretty much ignore the CV. And that's why we wanted to cast a wide net. We've since had more than 50,000 applications to our roles. So a ton of people have applied. And that also helped spread awareness, to be honest. That has also been, helped along that line. And a lot of the people that have applied, a lot of people that have contributed to the project have then gone on to continue to use it, tell their friends about it. And that's really enabled this word of mouth spreading that we're seeing at the moment. So I think, a few things, but certainly just getting the word out there and the hiring volume has certainly helped. Yeah.
That's really wonderful. I've found the same thing with our project. The second we decided to go open source, we got contributors from all over the world. In fact, contributors had previously contributed to Ivy.
I noticed, actually. I've seen a few. I saw that.
And they all talk super highly of Ivy and had a great experience there. And when they come into our project, they also know a lot more, and they bring a lot of really good ideas. And yeah, hiring all over the place. It's been really effective, and it also just feels good.
No, for sure. And I think that I think people miss out on just how powerful that is. I mean, I know there's a big push now to come back into the office and everything, and there are downsides. I mean, you do need to think quite carefully about how you keep people feeling engaged and how you keep people motivated when they're working from what might be their bedroom or their living room and so on. And over time, it does require effort to keep a fully remote workforce engaged and so on. But the number of exceptional engineers we've brought from Vietnam, from Egypt, from just all over the world, it is just and there's not that many top engineers. And I know that having worked in, top research labs, having worked at Amazon and so on, and you just miss out on such a global talent pool if you limit yourself to one city or one location. And I therefore think that you need to really think hard about, whether you want to close the door there to the global talent pool.
So when you started Ivy, was your intention to be an open source project, or you weren't even thinking about being a company, were you, at that point?
Yeah, no, not at all. We weren't thinking about being a company. I say we, it was just me as well. So just me with my...
In your PhD, with your cool project.
Exactly, yeah. So there was no intention at all. I just wanted to build something useful. But then the motivation to do the company, I suppose, came from a motivation to let the project reach its full heights. Obviously... I never really wanted to be a founder. I honestly didn't know what YC was until about 3 weeks before applying, and I didn't know what the VC acronym even meant. I didn't know what venture capital really was, so totally kind of off in my own world with the research and what I really cared about. And then the motivation to make it into a company was, well, a fully open source projects can never quite or often can't reach the full potential of how big the problem they can really solve is, and things that can fund themselves go on to solve much bigger problems. So I was always very problem focused and wanted to actually solve this fragmentation, and knew that I needed somehow to monetize that. Otherwise it's just going to remain, I don't want to be, there's a lot of amazing open source projects, but the motivation to turn it into a company was very much about the motivation to solve the problem in the biggest way. And it's been, a lot of fun so far, for sure.
Is there anything that worries you about the state of AI right now?
Good question. Maybe not the state of AI. I mean, to be honest, I've watched enough videos of people talking about AI to feel as though it's hard to say anything that doesn't feel a little bit cliched. But I think my immediate concern is a bit less about the AGI concerns, and it's just a bit more about whether we have the economic setup to deal with the job displacement and things like this. Broadly speaking, the world has seen increasing inequality in many countries. There's obviously increasing nationalism and everything. And like AI will, regardless of AGI and the trajectory that goes on, AI will replace drivers. It will replace people doing data entry. And that's a lot of people. There's a lot of kind of admin assistant style roles that could disappear. So I'm concerned about the general social unrest that could come from poorly managed policies around job displacement. That's my probably top concern. But on the more existential side, I mean, I do believe, I guess I don't quite, maybe somewhere between Hinton and LeCun, where it's like, I do think that it's potentially the beginnings of kind of AGI, and it wouldn't surprise me if in 5 years, I mean, I'm not saying that's what it is, but it wouldn't surprise me if the trajectory we're on does mean in 5 years there are like AGI that genuinely can engage with the internet in a way that's as sophisticated as a person could, if not more, and all the threats that come along with that, like, releasing a super drug or super bug or
Super drug would be pretty nice.
super drug would be nice, yeah. Super drug to combat the super bug. We'll have to have like a good rogue AI and a bad rogue AI battling it out.
I mean, I think this is also this is one of the current theories. People want to accelerate faster because we're going to end up with good AGI, which will combat the bad AGI.
Yeah, I also do buy into that camp a bit, to be honest. Like, I feel as though you can't stop the flood. Like, there are, autocracies in the world that are not going to stop. I mean, China are doing amazing research. Russia will continue to do research, and I think just putting a blanket stop on research is not the right answer. But I think putting a lot of effort into AI safety research is important. I do think we need to keep going because we need to understand this and know what it can and can't do. And I do genuinely believe that the more open, the better, though. I know that then if it's open source, anybody can then do fake news. But if it's so widespread, like people, I mean, I don't know. You can do arguments on both sides. And I don't have maybe enough kind of justifications here. But my sense is that open source is just better, because then at least the people can see when it's BS and when it's not, and can kind of moderate it to some extent. Whereas if it's closed behind a small number of companies, that to me doesn't feel great.
Have you been keeping up with the executive order and the European regulations on AI?
I haven't that much. I do know on a high level, but unfortunately I won't be the best sparring partner to discuss, but happy to kind of share high levels if you distill it down, but not too much, unfortunately.
I mean, I've heard a lot of concern that open source AI is going to be regulated. Is that something that you're worried about at all?
I think that would be a concern. It's very difficult with these things. Like, it's also very hard to comment on some of these things without sounding political or something as well, to be honest. But I'm generally an advocate for lack of regulation, and that even extends into things like Twitter. Now, there's a lot of downsides to having, hate speech and everything. That is not a good thing, but also trying to become the arbiter of what is and isn't acceptable, both in terms of speech, but also in terms of AI, is an impossible task. Like, who's going to take that responsibility on? And I don't know. Regulating open source seems the wrong approach. Again, unfortunately, I don't know the details in the context too much, so I'm kind of just taking what you've said, basically. To me, it seems like more maybe regulating the usage of it and the product of it, but regulating the neural network architecture and the weights or something feels wrong. It still feels like it's science, and science. It's also different to like building a nuclear bomb or nuclear reactor, where that's like a very physical, tangible thing. Like when you're talking about software in the abstract of like, it just feels like it would start to tread on the toes of research as well. And I think that some place in the world that will not be regulated, and we better be like understanding and learning about this stuff. Otherwise, This is my feeling, basically.
I think, like, now that you mention it, I really want to see regulations that require the usage of dropout. I think everybody should use dropout in their neural networks. It's at some layer.
I think so too, probably. Yeah.
Yeah, you have to have at least 30% of the network has to have dropout in it.
Yeah.
That'll be very good for research.
That would be very good. That's true. Maybe that's what they should come with. That's the final sentence on their policy, maybe.
So, given that you're so in the loop right now, where do you think research is headed on AI?
I mean, I'm glad that I appear in the loop. I'm not as in the loop as I was during my PhD, to be honest. I'm in the loop of the industry side of it way more, obviously, than the research side. But in terms of where AI is heading, I do think that one of the main stories of the last few years has been that with enough data compute, you can do anything. So I think the architecture seems to not matter that much. I mean, transformers are very good, but MLP mixers are very good. There was a recent paper showing that with enough data and compute, CNNs actually are competitive with visual transformers. So it seems like if we can keep getting more compute and more data, things will keep getting better. And that is kind of scary because it just suggests, well, when is that cutoff? And like, how close is it? So I think that's where AI is going. Let's make a load more GPUs and try to generate lots more data. Like the architecture, let's not stress about it too much. I mean, of course, researchers will and should continue to do that because we're not suddenly going to magically turn up, like hardware's not suddenly going to become 10 times more abundant and data's not going to do the same either. So you need to get shortcuts to do the best of what you've got now. But that's how AI's been, right? Like AI's been, right, this very simple neural network is going to be amazing, but we don't have the computer data. So let's do tree boosting and let's do decision trees that work well in the regime we're in. But actually, no, this very simple idea from the 80s prevails. And I feel like in reality, to get AI really, really intelligent, my gut feeling is we don't need that much more. Well, who knows? But my gut feeling is we might not need that much more algorithmic insight if we had enough data and compute. I mean, evolutionary algorithm of life generated us. That's an incredibly simple algorithm running with a lot of data and a lot of time. My gut feeling is that's how very complex emergent intelligence will always arise, and it won't come through like too much human heuristics. I mean, that's a very broad sweep of where AI is heading, but I think just to add one more point there, that's a bit less big, a bit more reined in. I think that compilers, which I'm very interested in, I think they will continue to be AI driven. And I think there's been some really interesting research, such as Alpha Tensor with DeepMind, discovering matrix multiplication algorithms that are superior to any human heuristics. And there's also great research. There was a paper recently by Meta. We did it in our paper reading group, actually, that was like, it was just called Large Language Models for Compiler Optimization. And they showed that you can just take Llama 2, 7B, and predict the LLVM optimal flags, and it can actually improve upon the best heuristics in LLVM for compiling just by training one LLM on this very simple task of predicting optimal flags for the compiler. And I think at some point it might be the case where we have a model and we have this mathematical model, and then we can have an optimization algorithm that's AI-driven that spits out assembly, and it's better than anything we can comprehend. We don't know how it's done this, but it's maybe implicitly done some quantization and some compression and some sparsification and some kind of algorithmic wizardry like flash attention just emerges, and we don't even understand. Not only do we not understand the mathematical model, but we don't even understand how this relates to assembly, and it's just 100 times faster. This is kind of where I think things might go in the compiler space, which is scary and exciting. Anyway, these are two thoughts of mine on that question.
I mean, you guys are kind of writing compilers, right?
We are kind of. The reality is, so
interpreters, maybe.
No, we are. No, we absolutely are. So Ivy's we've now called it the tracer, but we've written a tracer and a transpiler and a compiler, which means you can take PyTorch code. You then trace the computation graph, for example, and then you can take that graph and kind of transform it into TensorFlow or so on. But on the deployment side, we're working we're working with XLA and OpenAI Triton and so on, and sometimes pure CUDA kernels to push the performance of the models that we're working on. Jumping ahead a bit, so there's effectively two products. One of them is Ivy, which is this framework which you can use to write new code and then convert code between frameworks, and this kind of has a compiler. It certainly does function tracing to trace a graph, which has a compiler flavor. On the engine side of things, right now we are heavily optimizing specific models, both that are very popular, but also that come through from kind of requests from, our sales leads and so on. And then we're building this heavily optimized model hub. And the abstractions that enable us to automate this process where you upload any model and then that model is automatically made much faster, that's something that we've pushed back a little bit, because what we've found is to really, really get models going as fast as possible, right now you do still need to think about them as point solutions. If you want a model to be running as fast as possible, it's very hard to get a compiler that can spit out Llama CPP or can do kind of what GGML does off the shelf. So we're kind of focusing on point solutions in a model hub with the intention of then abstracting this logic with compiler logic over time. Again, I'm unpacking quite a lot. Maybe on a high level that makes sense.
What's some advice that you would have to any aspiring open source founders?
Advice for aspiring open source founders. Good question. I guess, well, first of all, advice to founders in general is obviously just try to build something that you're passionate about. I think the novelty of being a founder for the sake of being a founder wears off incredibly quickly. I love being a founder, but I love it because of the problem that we're solving and kind of the vision that inspires in me every day. So I think it's good if you can work on something that you genuinely are passionate about. I mean, that's important. And on the open source side, I guess, to make a bit more specific to the question asked, I would say, I guess you need to think quite carefully about where you draw the line between the open source and the enterprise side. And I guess you do need to spin two plates a little bit. This is what I'm finding. You need to keep the open source community engaged because they are, they're an incredibly important part of your whole story and what you're building. And they're going to be your biggest backers, and you need to give them the love and respect that they deserve as the people that are really your champions really out there. So you need to make sure you give them an amazing experience, give them something they can use that they love using, they don't need to pay for and everything. But you can't only optimize that. You need to make sure that what you're building isn't just something that's free and that's all it's ever going to be. So you need to make sure there is an enterprise component as well and think very carefully about that. And to be honest, for me, I think you also need to accept that even for an open source company, which has these new distribution channels with potential for kind of bottom-up adoption, and you should leverage those, you need to be comfortable with the fact that, in my mind, you need to be comfortable that you should also be thinking about top-down sales as well. I think people ask, is it top-down, is it bottom-up? I personally think both is better than one or the other, and we have had leads come in from us. We've also done quite a lot of outreach trying to get introductions to our investor network and their portfolio companies and so on, and we've had deals close in both regimes, and I think you can't shy away from that. You still are trying to be an enterprise and you're trying to close big enterprise contracts, and they're not always going to come finding you because of your open source project. So it's quite hazy advice, but I guess you need to accept that you're spinning two plates and you need to keep spinning them both. In my mind, that's how it feels like.
Yeah, I love that. Actually, when I finished YC, their comment to me was, "You spent all of YC philosophizing too much," and it was like, "Oh no, my heart is broken." And after that, I put at the top of my Discord, in my constitution, just do things.
Yeah.
Just do more things and don't think about it. And ever since then, I'm just I don't care whether I'm doing top up or bottom or top down or bottom up sales. I'm just gonna do them.
And you need to try as well. Exactly. I think there's this whole philosophy of just take more shots on goal, launch things quickly, release things, try doing some top down, see if it doesn't work, try build the community. And I think you just need to be trying lots of things and getting out there and not dilly-dallying about decisions, and you learn from experience. You then get the signals just from having done it and seeing what happens. So again, another piece of somewhat cliched but very valuable YC advice, I think.
Yeah, I think we can't hear it enough times.
Yeah, absolutely.
Anyway, this has been really wonderful. Thank you so much for coming on.
Yeah, likewise. Had a lot of fun. Thank you very much for having me.